Hey everyone, and welcome back to this class, Support Vector Machines in Python. In this lecture, we are going to introduce the next section of this course. This section of the course is nice because it is friendly to both beginners and experts. So if you made it through the tough theory parts of this course, then you'll find that this section will help you build your intuition further and make more sense of the concepts you've already learned. If you're a beginner, then this section will give you more intuition about how the SVM works to become a powerful nonlinear classifier. The outline of this section is as follows. First, we are going to introduce the RBF network. RBF stands for Radial Basis Function. The idea behind the RBF network is that you're going to take the training set and set up several important landmarks or exemplars. Then you can use this to build an automatic feature vector, which is simply made up of the distances from your test point to each of these landmarks. Once you have this, you can pass it into a regular linear classifier and train it using gradient descent like you normally would. Next, we are going to look at a funny approximation of the radial basis function, which helps it work a lot faster. What's very interesting about this method, called random kitchen sinks, is that to find the parameters of this model, you don't actually make use of the training data. The author of Random Kitchen Sinks wrote a popular blog post about how machine learning is the new alchemy, and made a reference to this method in that blog post, which caused a little bit of controversy in the machine learning community. Earlier in this course, we demonstrated how an SVM with a sigmoid kernel has almost the exact same equation as a neural network. In this section, we are going to take that idea further. Specifically, we are going to build a neural network, but instead of training the input to hidden weights, we'll instead just randomly set the weights to the input data. This will mimic precisely what the SVM is doing, although in that case, the input data is not selected randomly. So that should be very interesting. Instead of backpropagating the error and updating all the weights, perhaps the weights simply making a copy of the training data is already quite good.